Today we're going to talk about trigonometric functions. This is the big idea. I'm going to use the big idea to set up what I'm going to show you to do today. The big idea is actually a lot more complicated, but I'm going to keep it simple. So we're just going to use one simple angle that you're all familiar with by now, I hope. No. Okay, so this is a 30-degree angle, correct? And if this is a 30-degree angle, then this is x, and this is y, correct? And that's how we get to pi over 6? Okay. So let's define in terms of x, y, and r. Remember, this is r, the radius of the circle. And on the unit circle, what is the radius always? 1. That's why we call it the unit circle. You could have something larger than that, right? But for our purposes, we're going to keep it at 1. So sine. Sine is, see, we have our so, ka, toa. Most of you have gone away from this, but just for the visual. So sine would be opposite over hypotenuse. What would opposite over hypotenuse be from this angle? Y over 1. Right? Y over r, but I'm just going to put y over 1 for our purposes. Got it? Look in the book, it's not going to say y over 1. It's going to say y over r, and it's going to get complicated. Okay? All right, cosine. What would cosine be? Adjacent over hypotenuse. X over 1. What would tangent be? Y over x. These are the inverse functions down here. So if this is y over x, what's this? X over y. And what would this one be? 1 over x. And what would this one be? 1 over y. This is what I want you to get from this. Sine is y. Cos is x. Today. For whatever you need right now, that's all you need to know. Got it? Okay. So let's define in terms of coordinates now. Let's use that. We know the coordinates now. I understand there are coordinates all the way around here. I am only going to define the coordinates of pi over 6. So what are the coordinates at pi over 6? What? Root 3 over 2 and 1 half. What did I say sine was? Which one's y? What's cos? So it's square root of 3 over 2. Tangent is y over x, which would be, I'm going to skip a step here, 1 half divided by root 3 over 2 would be 1 half times 2 over root 3, correct? But that's kind of, you can't have a square root in the denominator, so if you multiply both sides, the denominator, it would be root 3 over 3. Good. You're good Algebra 2 students. You should be able to do that. Okay, what about this one? 2 secant. Okay, you can't have, so 2 over root 3 would really be 2 root 3 over 3. And what would this one be? 3 radical 3 over 3 after I simplified it? Right? Okay. Don't need to write it down? Not needed. The only thing you need is right here. This is all you need to know. I'm just showing you how, why. If I were to say, hey, sine is y and cosine is x, would you, I mean, you'd believe me, but I'm showing you why. Can you see why? Okay. So that's all we're going to use today. Sine is y, cos is x. Yes? No. Don't use decimals. Absolutely not. You're not going to pass the final if you use decimals. Okay. Yep. It's all I did was take the inverse. That's it. You don't want to use decimals at all. You want to keep everything in these fraction friendly.
On the finals, they don't want decimals.
They won't give you decimals. Okay. All right, so find the value of the given trigonometric function. So this is your homework. So go ahead and write down number 1. It will go in order. I'm going to do half of them with you, of the new stuff. You have 20 problems to do for homework. We're going to do 1 through 6. I'm going to leave 7 through 12 for you to do on your own, and then we can work together on the rest of them if you want. Should have time to get through most of it. Okay, so let's begin with sine of 1,485 degrees. Forget the sine. You know something about degrees. What do we know about degrees in the unit circle? To go in full rotation, it's 360 degrees. So there's lots of ways you could break this down, but let me show you how I broke it down, and then I'll show you, I'll show you a different method for the second one. Okay? You may come up with a third method or a fourth method. All right, I said, well, I want to know how many times around I'm going, because I don't need to know. I'm basically going around and around and around. Then I'm going to land somewhere, right? Kind of like Wheel of Fortune. Okay. So I took 1485 and I divided it by 360. I got 4 point something. All right, that tells me I've got 4 rotations. So I can go around 1, twice, 3 times, 4 times, and now I'm going to figure out where I'm going to land, because I'm going to land somewhere in here now, correct? Okay, so I went around 4 times. I said to myself, well, I'm going to figure out how many times 4 times 360 degrees is. So 360 times 4 is, I believe, 1440. So then I took 1485, and I subtracted 1440, and I got 45. We call this our reference angle. It's not the actual angle, but it's where we land, and that's where we're going to reference on our unit circle. So I landed right here. So we landed here. Well, at 45, that's pi over 4. What are the coordinates of this location? Root 2 over 2, root 2 over 2. What does sine mean again? Which one's y? Pretty easy, huh? But if you didn't have somebody sit there and explain to you, it's kind of a little complicated. No, I know how to break things down because I like them broken down to me. Okay, I'll let you guys write that down, and then you guys need to do number 2, and I'm going to do it just a little bit of a different way. Are you ready? Okay. This time I'm going to switch it into radians. So forget the secant. Let's just figure out the degrees. I really don't, with the unit circle, I don't like working in degrees. Some of you may like it. I don't like to second guess where am I going to land on degrees. I'd much rather, radians to me are much easier to use, but that's up to you. So if I wanted to convert degrees into radians, what would I multiply by? Oh, look at you guys. Pi over 180. My 10s cancel, and I'm left with 114. Well, 2 times 114 is 57, and 57 is 3 times 19 over 6 times 3. 2 times 3 is 6, so that cancels that 6. Can't forget my pi. So I'm left with 19 pi over 3. Well, 19 pi over 3 is an improper fraction. How would I turn it into a mixed fraction? 3? No.
How many 3s do you have in 19?
How many 3s do you have in 19? 6. Now this is where it gets a little tricky. It needs to be an even number because going around the unit circle is an even number. It's 2 pi. So does 6 pi go around the unit circle evenly?
Yeah.
How many times does it go around? 3 times. Good. Okay, so I have 6 pi. We'll just leave it like this. 6 and how many left over? 1/3 pi. Couldn't I write that like this? 6 pi plus pi over 3? You suppose? So isn't that going around 3 times and then landing where? I should have done all of this in a different color. It was really, really dumb. Let's see if it'll let me change it. Oh, look how smart. Isn't that fantastic? Don't you love technology? It's like done. Solved.
It's not always the case with color.
So, 1, 2, 3 times around, and where am I going to land?
On the pi over 3.
On the pi over 3. Well, that's good because we know the value at pi over 3. Maybe. So pi over 3, what are the coordinates at pi over 3?
1/2 over, what is it, over 2?
3 over 2. In the unit circle, you really only need to memorize 2 things, right? Because this one's just switched. It's really not that much work. So as long as you've been doing it and practicing it, by now you should be like, man, this stuff is easy. Okay, hold on. So, secant, all right? Secant is an inverse. Inverse of what? Sine or cosine? Cosine. Remember, sine and secant don't go together. For some reason, they wanted to confuse us. So sine goes with cosecant, and cosine goes with secant. Remember? Okay. So secant goes with cosine. Well, what is cosine? What is x? So what is cosecant? So therefore, I'm going to write, therefore, secant is 2. Yes, sir. You don't, it's just preference. It's totally preference. Couldn't I have just figured out how many 360s were in there and then landed on degrees? I would have gotten the same thing. Yep. I like turning it into radians.
Is that always going to work, or will we have to do the other one?
No, it'll always work.
Oh, okay.
Either one will always work.
So it'll always land on one of the given?
Yep. Yes. I can't hear. I don't want to talk over you. Y over X. Yes. No. Yes. Because going a full rotation on the unit circle is 2 pi. So 2 pi, 4 pi, 6 pi, 3 times.
So it wouldn't
Yes.
work if you got 5?
No.
How much do you want to draw?
No. I'm not going to draw it anymore. Yes. If cosine is secant, then sine is cosecant. Sine is cosecant, cosine is secant, tangent is cotangent. They're all inverses of each other. Okay? Ready? Let's do it the other way. Okay? In fact, you know what I think I'm going to do? Oh, wait. I wanted to show you one without... This isn't the one to do it. Okay, so now I have cosine of negative 23 pi over 3. Well, 23 pi, how many 3's go into 23? 7's not going to work. 7's not going to work.
Wait, so you could take 6 and then...
So we'd want to take 6 pi. Okay. How many, so if I had 6 pi, it would be 18 pi. How would I get from 18 to 23? So I'm going to do 6 and 5 pi over 3. Does that make, I mean, this is what, 4th grade math? Does that make 23 pi over 3?
Yeah.
Because the denominator is 3. Well, isn't that how we figure out how to make a mixed?
Yeah.
Yeah, it's exactly the same thing as turning an improper fraction into a mixed fraction. Same process. Only we don't want this number to be odd. It's got to be even because to get around the unit circle, that's an even rotation. Make sense? Okay. So, can't I break this up? This would be negative 6 pi and negative 5 pi over 3. Make sense? So I would go in the negative direction around 3 times. I'm not going to draw it. I would start here, and I would have to go negative 5 pi over 3. Well, okay, when I look for reference angles, guys, I look at, well, I may not know where negative 5 pi over 3 is, but if I go in this direction, I know that 5 pi over 3 is way over here in this 4th quadrant. So if I was going in the negative direction, where do you think I would land? Right there. Make sense? And if that doesn't make sense, you could just count. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So 5 pi over 3, the reference angle for 5 pi over, or negative 5 pi over 3, is pi over 3. So this is pi over 3 or negative 5 pi over 3. What are my coordinates at this place? No. 1/2, comma, root 3 over 2. Cosine means x. What's my x coordinate? 1/2. Good? I'm going to do this one like a homework problem because you won't have this for your, I mean, you can reference it, but this is how I would draw it myself. So I'm going to do cosec. Get pencils down. Just watch how I do it, guys. I'm going to say, okay, first I need to turn this into a mixed fraction. So 3 goes into 19 6 times. So that would be 6 pi plus 1 left over, pi over 3. All right, I know where pi over 3 is on my unit circle. Pi over 3 is not here, but here. That third one is 1/2 root 3 over 2 cosecant. Well, cosecant goes with sine. Sine is y. That would be root 3 over 2. But I need cosecant, so I'm just going to flip it over. That's 2 over root 3. But I know that I have to change that to 2 root 3 over 3. And there's my answer. Pretty easy, right? Okay, copy that down. So you don't need this. And I should have made that in a different color. I will do that now. I missed this one. There we go. 3, 2, 1. Okay, so you may be tempted to start doing a bunch of work, but what do you see in here? I see 360. What's 660 minus 360? Well, I don't know where negative 300 is on here, Mrs. Mahler, but I do know that 300 plus 60 makes, so if I was rotating around in the negative direction, wouldn't I just stop at 60? So isn't that negative 300 right there? So this one, it was easier to just think about it rather than turn it into radians. So this is 1/2 root 3 over 2. We're talking cosecant. Cosecant coincides with sine. Sine is y, which is root 3 over 2. So cosecant is 2 root 3 over 3. You guys got this? Here's number 6, and I'm going to pass out your homework. 3, 2, 1. Okay, so you guys should have got 2 for this one. Let's see how we got that. We'll do with our little makeshift unit circle over here. So root 13 pi over 3, how many times does 3 go around? 4 times? So 4 pi plus how many left over? Pi over 3. That's our reference angle right here. So pi over 3 is right here, which is 1/2 comma root 3 over 2. We're talking secant. Secant coincides with cosine or x, which is 1/2. Therefore, secant would be 2.
Miss Mara, can I go tell them the teacher of the year is trying to teach right now?
They're doing something fun. I already saw. I know they're being loud. All right, so let's close this up. What did you learn today? Okay, who can tell me what a reference, how do we use reference angles?
We find our
I say to cut out what we don't need, right? Awesome. When finding the value of a trigonometric value, you can tell I did this late. Given a certain degree, folks, what are 2 strategies could use? When you're using degrees, what 2 strategies, Evan? You could change it in radians or just use 360 and stick with degrees. Okay, Evan, let me stop this. What?
every time it happens in a sequence,
No, it just happens to be where it's landing. If it landed on pi over 6, it would be the reverse. If it were to land on pi over 6, these numbers would be switched. So if it asked for the secant at pi over 6, that would be 2 root 3 over 3, because the numbers are switched. Because that doesn't have anything to do with it. It just happens to be a coincidence that it keeps landing there. But your homework won't be like that. Yes? No, tangent is y over x. Y over x. All right, let's look at it.